Hi, and welcome to the first oceanography discussion PowerPoint. And this one is titled Oceanus. We're looking at Module 1, which is basically the water planet. We'll be doing chapters 1, 15, and 16. And so the first question I want you to do, I want you to pause this video real quick. And why do we care about oceanography? Why should we care? So go ahead, pause the video, jot down some options or some ideas you have about why we should care about oceanography. And then restart it because we make sure these out in class or when we get to or in Canvas, depending on what we're doing. So why do we care about oceanography? And then I'll give you some of the reasons why I think you should care about oceanography. So go ahead and pause it and then restart it. So things to think about in terms of why we should care about oceanography is the ideas of biodiversity, medical potential drug discovery in the oceans, new climate, new models of life. We got climate, we got fisheries, recreation, fossil fuel resources, ocean energy, navigation, carbon cycle, marine biology, hazards. And it was my hope that you may have jotted down a few of those, but I'm not holding my breath. So these are just some of the things that why we should care about oceanography, but also some of the things that we're going to talk about as we go through the course over the course of the semester. So we look at ocean energy. There's a lot of ability. When we think about ocean energy, we can think about getting the resources from the ocean bed, such as oil, but also looking at things like putting propellers or wind turbines out there at sea where there's a lot of energy produced. And so if you look here in the United States, these are all platforms, right? We're talking about oil platforms. There's a legend, kind of tough to see. If you remember Deepwater Horizon, that is up here, and this is all along the coast of, this is Louisiana, so this would be the Gulf, and into parts of Florida. So there's a lot of stored energy, available energy located underneath the ocean in the bed. There are some ocean hazards, though. Sea surface temperatures in the tropics fuel hurricanes. At this point right now, when I'm recording this, there's two tropical storms. I think one may be a hurricane now. I'm heading for Louisiana. But so what we're going to probably talk about, we'll talk about this more towards the end as we talk about what a tropical cyclone, the number and duration, and if we look at the number of intense hurricanes over the course of time, you can see there's a general increase. Ocean drug and discovery, again, there's a lot of potentials for finding drugs that can be used to treat all kind of human issues. And then, but again, we also about ocean climate. It does play a dominant role in heat transport and mixing. So the way that thermocline works there, what is in the blue colors tends to be colder water. And as you get to the tropics, you can see where it turns orange or red. That's really where you have a lot of heat. And so the ocean and water in general plays a dominant role in transporting heat. Again, ocean climate, vortices, these are mixing in the ocean and they influence the ocean circulation biology. So they're at the Gulf of Alaska. You might start to see swirling patterns. And so there's a lot of important productivity locations there in these vortices and where these waters mix. And then we'll talk about climate change as well. So if we look at sea level rise over the last century, we do see a change in sea level. And then if you see the ocean temperature index, there is an increase. So we are changing or whatever. The cause is that there is a change definitely in the ocean, the climate. And so again, and here's just global surface temperature and sea level rising again. Marine ecosystems are important because some of these marine ecosystems are the basis of a lot of food webs and food chains. So they can also affect fish distribution. Specific types of fish can only live in specific type of water temperatures. And so sardines and anchovies, right? As you can see, the peaks and lows, right? And so there tends to be these synchronized alternations between sardines and anchovies in the entire Pacific. So you have a sardine regime, anchovies, sardine, anchovy. And so are we now in an anchovy regime? That just really depends on climate. And then a carbon cycle. And so with the carbon cycle, marine ecosystems regulate the cycling of chemical species relevant to climate. So this is like chlorophyll spring 2005. So the darker green areas are where you have lots of chlorophyll, which means you have a lot of plant growth. And the areas where you don't have a lot of green, not so much. And if you think about places that are deserts, Northern Africa, the west coast of South America, a lot of Australia, these are areas that if we were to look at the way that the ocean is circulating, we'd probably also see the fact they're not bringing in certain types of water or regulating the climate there. And then again, it's just your carbon cycle. And again, marine biodiversity, if those of you that have me for biology know, the more diverse the ecosystem, the more stable. And so this is a coral reef, and you would want to see a coral reef with lots and lots of diversity there, because if it has lots of diversity, it means it's very stable. We will talk about ocean acidification. We'll also talk about coral reef collapse. And so when you have a less stable environment, less stable ecosystem, this is when you tend to see issues with like coral reefs failing. And then also looking at the ocean, we can also look at the ocean as a new model for life, especially if we're looking at these deep thermal vents and how these things that exist nowhere else on Earth exist near these areas where there's really hot water. Or if we look at ocean, we can see the past history of the Earth by looking at the layers of the material found in the sediments. So how do we define oceanography? So it's interdisciplinary, which means that in oceanography, we're going to talk about geology, like seafloor tectonics, geography, wind belts and weather, biology, fisheries, ecological surveys, chemistry, looking at dissolved components in salt water or seawater, chemical tracers, physics, currents and waves, and astronomy, tidal forces, origin of life, because you can't talk about oceanography without talking about all of these. It's not a standalone concept. So hopefully that was just your introduction. Like I said, I'm going to try to keep these my discussions from like 6 to 7 minutes, but hopefully if you got any questions, feel free to either email them if we're in class, ask them. But this was our first quick intro. So again, please go back and look at your like why we should study oceanography, and then add anything else you want to it. So this is me signing off for our first oceanography session.